Hello students, very good morning. Dear students, we have started the study of main group elements, and in that we have already completed the last group, that is halogens. Today our topic is noble gases. We are going to start a new lesson, new chapter, and the title is noble gases. We know that these noble gases are the part of P group, P block elements. All noble gases are, these are all P block elements, and all these noble gases, they are belonging to the 18th group of elements. 18th group. All these noble gases are belonging to the 18th group of the modern periodic table. Okay, now the names and symbols of these noble gases, we are already familiar with this. Okay, let us see, or let us revise these noble gases. So first one is helium, okay, having atomic number 2. Then second one is neon, atomic number 10, argon 18, krypton 36, then xenon 54, and last one is radon 86. So these 6 elements are there, and these 6 elements constitutes a group known as 18th group of elements, and all these elements are known as noble gases. Dear friends, these noble gases have different names. When the Mendeleev prepared first time his periodic table, at that time also he was unaware about the existence of these noble gases, and after some years, when the spectra of sun has been studied, then some extra spectral lines have been observed by the scientist, and at that time it is concluded that that extra spectral line is nothing but of helium, because helium is the major proportion on the sun surface or the sun atmosphere is having the helium gas or helium element. Okay, so that's why that spectral line was belonging to the helium element, and from that period the new elements have been discovered by the different scientists, and they are known as noble gases or inert gases or rare gases. Okay, so that's why we will see how these noble gases or 18 group elements were named as per the time these names were put forth by the different scientists. But nowadays these names, that is rare elements or rare gases and inert gases, these names of these group, these 18 group elements are not correct, or we can say they are incorrect. Okay, so why? Let us see the reasons. First one is rare gases. Rare gases. Now, when we use the word rare, if the proportion of or the amount of that particular substance is very rare in the atmosphere, in the nature, in the earth crust, in the universe, etc., then we call them as a rare. But when we study the atmospheric gases, we know that about 78% of the atmospheric gases, the 78% volume is occupied by the N2 gas, that is dinitrogen gas. Okay, the 19%, approximately 19% of the gas is nothing but oxygen, that is O2. Okay, and we know that carbon dioxide is only 0.03%. Carbon dioxide is only 0.03% present in the atmosphere. But the argon gas, which is one of the noble gas or 18 group element, is found to be exist in the atmosphere having percentage more than that of CO2. Having percentage more than that of CO2. Now, if the argon gas is present in the atmosphere or its proportion in atmosphere is more than CO2, we cannot say CO2 is a rare gas. So how we can say that the argon is a rare gas? So that's why the name rare gases or rare elements is not correct, or we can say it is incorrect for the 18 group of elements. Okay, so that's why this rare gases, this nomenclature, this name is incorrect. Then the next name is given for these elements, which is nothing but inert gases. No doubt these gases are inactive. Inactive means they are very low reactivity. They are having very low reactivity. But they are not totally inert. Hence, as they are not totally inert, because the element xenon is capable of forming compounds with fluorine and oxygen. Both are electronegative in nature and capable of ionizing the xenon element. Okay, so that's why xenon fluorides and xenon oxyfluorides, such compounds can be seen, and that's why we cannot say that all these 18 group elements are the inert gases or they are inert elements. We cannot say. So that's why these inert gases or inert elements, this name is also incorrect. Okay, and hence the correct name that is noble gases, which means the meaning of noble gases, though they are having low reactivity, but they are having low but significant reactivity. All noble gases, all 18 group elements are having very low, they are having, we can say very low, but having some significant reactivity. Okay, so that's why the meaning of the term noble gases has been extensively accepted, and that's why this is the reason why rare and inert gases are incorrect and noble gases, this nomenclature is correct. Okay, now we will see how these noble gases are named after their discovery. Okay, so we know that the sun atmosphere or on the surface of sun, the nuclear fusion reactions of hydrogen atoms are taking place continuously to produce helium nuclei. So that's why the sun surface is made up of large amount of helium, and hence this helium, its Greek word is, the name helium is derived from the Greek word helios. The meaning of this helios is sun. It is sun. Why sun? Because helium is occurred on the sun surface. Then neon. The neon, Greek word is neos, which means new. The neon element was new at that time, so hence it is named as neon. Argon. Argon means argos, which is derived from the word argos, and the meaning of argos is inactive. Inactive. Okay. Then krypton, it is derived from the kryptos. Kryptos, and the meaning is hidden. The meaning of krypton is hidden. And the xenon is xenon. The meaning of xenon is it is derived from the xenos, and the meaning of xenos is strange. The meaning is strange. Okay. And this radon, the name of radon is not derived from the Greek word. Okay, but this radon, Aryan, is named after the element radium. After the discovery of element radium. Okay, so this radon is actually a byproduct of radioactive decay of this radium. Okay, so when radium undergoes radioactive decay or radioactive disintegration, it is producing radon. Okay, so that's why we can say that this radon is a byproduct of radium. Radium is also radioactive, and hence this is named after the element radium. Okay, so these are the some Greek words from which the names of these inert gases or noble gases have been derived. Okay, the meaning of these are also given. Okay, now the next point is occurrence. Occurrence of these noble gases. We know that they are very less abundant in the atmosphere. Occurrence. The abundance of these elements, noble gases, is very less as compared to other elements. Okay, but they are not rare actually, because here helium, we know that helium is present on the sun surface, so that's why in the universe helium is the second largest abundant element. Helium is the second largest abundant element by mass in the universe and sun. Okay, so when we study or when we take into consideration of universe and sun, because sun is also included in the universe, after hydrogen, so hydrogen is at the first number. After hydrogen, this helium is at the second highest position by mass in the universe and the sun. Okay, and it is actually 23% by mass. Okay, then this high concentration of this helium have been observed in the natural gas deposits in United States of America and Europe, in USA and in Europe. So in these two countries, in United States of America and in Eastern Europe, in these countries some natural gas deposits are there, and at that place the high concentration of helium gas have been observed. Okay, then this helium from these places, this helium can be recovered by low temperature distillation. So this helium gas can be recovered from these places by process known as low temperature distillation. Okay, then except this helium and except radon. Okay, so except helium first element and radon last element of this 18 group element, the middle four, that is neon, argon, krypton and xenon, these four elements are found in the atmosphere. Okay, so the argon gas, we know that this argon gas is having more proportion in atmosphere than the carbon dioxide gas. Okay, and it is 0.94% in atmosphere. Argon gas is found to be 0.94% in atmosphere. Okay, and we know that CO2 is 0.03%. So that's why this argon is having very large proportion in atmosphere as compared to CO2. Okay, and after argon, the neon gas, it is found to be 1 into 10 raised to minus 3%. Okay, that is actually 0.001%. Okay, 0.001% by volume neon gas is present in the atmosphere. Okay, the xenon and radon, these are the rarest element of the 18 group. Okay, so out of the 6 elements, this xenon and radon are the rarest element present in the 18 group of element. Okay, so this is all about the occurrence of noble gases in the atmosphere or in the earth crust. Okay, now the next point is uses of these noble gases. Actually this uses is last point from our syllabus, but we will see it in the continuation of this occurrence. Uses of noble gases. Uses of noble gases. First of all, we will see the uses of helium. Okay, so helium is having low density and non-flammability. So it is non-flammable, it is not catching fire, and it is having low density. So due to these two features, this helium gas is used to make balloons or to fill in the balloons. Okay, so due to these two features, low density and non-flammability, so helium balloons can be prepared by using this helium gas. Then second, the boiling point of this helium is very low. Boiling point is very low. Okay, so that's why at room temperature it is gas. At room temperature it is existing as a gas, and this property of this helium gas, it is used as a cryogenic substance. Cryogenic substance means this is the application of at very low temperature, or use or application of this helium at very low temperature. Very low temperature. This is known as cryogenic. The meaning of word cryogenic. Okay. This helium gas can also be used as a coolant. Can also be used as a coolant in magnets, in strong magnets used in NMR spectroscopy. Okay, so we know that NMR spectroscopy is having strong electromagnets, and in that we have to maintain a very low temperature for that strong magnets. So in such case, this helium gas is used as an coolant in this NMR spectroscopy as well as in MRI, that is magnetic resonance imaging. So in both MRI and NMR, so this helium gas is used as a coolant. Okay, then it is also used as coolant, inert atmosphere. It is also used as inert atmosphere in the crystal growth of silicon. In the crystal growth of silicon element. Okay. Then this helium gas, when it is mixed with 4s1, so 4 part oxygen and 1 part helium. Okay, so this mixture, this proportion is used for the divers. This proportion is used for the oxygen atmosphere, or for making the presence of artificial breathing for the divers. Okay, so the divers means the persons who are diving in the deep sea or the deep ocean. When the divers are taking a dive in the deep sea or deep ocean, they take cylinders, they take oxygen cylinders, and in that oxygen cylinders the proportion of that mixture of gases is 4s1 by oxygen and helium. So these are some uses of helium. Then argon, we know that argon is very inert. Out of all these 6 elements of 18 group, argon is the having very less reactivity, and hence we call it as a inert gas. Very inert gas, and due to this inert gas property, it is used as a inert atmosphere. It is used for inert atmosphere in air sensitive or moisture sensitive reactions or production. there are some reactions, there are some processes where we have to brought an inert atmosphere. Okay, so for that we may call some reactions are air sensitive or moisture sensitive, and in such cases this argon gas purging is generally used to maintain the inert atmosphere for that particular vessel. Okay, then this inert gas argon is also used to fill in the balloons. Okay, so argon balloons are also have been prepared. Okay, then it is also used as a blanket, inert blanket, we can say inert blanket for the over the surface of metals when they are welded. So when metals are welded with the help of welding machine, okay, so to maintain inert atmosphere at that surface, so this argon gas has been used. Okay, so these are some uses of argon gas. So this argon gas is also used as a cryogenic refrigerant. Cryogenic means at very low temperature, cryogenic refrigerant. Okay, so these are some uses of argon gas, and some miscellaneous uses of inert gases are there, and they include these inert gases can be used for the production of lamps, Okay, for example, fluorescent lamps, then LEDs. Okay, so these inert gases, due to the inert property of these gases have been filled in the inner atmosphere of these lamps, and hence such fluorescent lamps or LED lamps can be made with the help of these noble gases or inert gases such as argon. Okay, or some lasers can also be prepared with the help of these inert gases or noble gases. Okay, so this is all about occurrence, introduction, occurrence and uses of noble gases. So this is the first topic of this noble gases. The remaining topic of this chapter we will continue in the next video lecture. Thanks for watching this video. Have a nice day.